Well, once again, I've run out of time on the individual recordings because they can only be 15 minutes long. So let's continue this. Remember, constructing confidence intervals. The estimate, which is either X bar or P cap, plus or minus a margin of error. That margin of error is the critical value, which is a number that we'll find is a little bit more precise than 2 later on, but 2 standard deviations, and the standard deviation of the statistic in this case was the 5. So this form comes over and over and over, depending upon what you wanted to estimate. The statistic could be X bar, could be P cap, could be sigma sub X bar, it could be anything. It could be S, I guess, which is a standard deviation of a sample, plus or minus some critical value, and we'll find once again will be a little more accurate, and then that standard deviation of the statistic. That's the point estimator. Estimator is the statistic. So, properties. The margin of error is the critical value times the standard deviation. The margin of error is that product. That's what you're adding and subtracting to the statistic. So when you hear margin of error on TV shows or news shows, that's what they're adding and subtracting. It's some critical value times the standard deviation. And we'll talk about critical value in a minute. User chooses the confidence level, and the margin of error follows from that choice. So when they choose 95%, that's what's going to drive this. Critical value times really the critical value. The critical value depends on the confidence level and the sampling distribution of the statistic, which is that standard deviation. Greater confidence is larger critical value, so it'll be a wider interval. The standard deviation of the statistic depends upon the sample size, so the larger the sample, the better the standard deviation is, the more accurate. 2 important cautions. Our method assumes the data comes from a simple random sample size n from a population of interest. The margin of error in a confidence interval covers only chance variation due to random sampling and random assignment. So let's do one. Candy bars. Consumer watchdog has been eating too many candy bars, estimates the mean weight of a 1 ounce fun-sized candy bar. See if the customers are getting their full value, so they eat a bunch of them, about 25 bars. Selected and weighed, and they got 90%. They report that a 90% confidence interval of the true mean weight is 0.992 to 0.988. 0.992 to 0.988. They've calculated that. We haven't learned how to do that yet. Well, we can find the point estimate because remember, the point estimate is in the middle of this interval. So it must be the average of these two. When you take and add these two together and then divide by 2, you should get that point estimate in the middle of that. So 0.995. Add 3, or 0.003, or subtract 0.003, you get that 0.995. That must have been the P cap, the point estimate. Not the P cap, this would be the X bar, the average weight. Sorry. What is the margin of error? Well, that's what you had to add and subtract to that P cap to get the 0.998 or the 0.992. So the margin of error is the 0.003. So interpret the 90% confidence interval in context. You're going to say almost the same thing every time. We can be 90% confident, put in this percent here, that the interval from, and then you put in the interval, 0.992 to 998, will capture the true mean if we're talking about means or true proportion of the candy bars. Interpret the confidence level. Now this really is almost the same thing, it'll seem. It's sort of going backwards. If we take many samples of the same size from a population, from this population, this particular one, about 90% of them will result in an interval that captures the actual mean weight of candy. Once again, a lot of times we just fill in the blanks. If we take many samples of the same size from this population, that's always the same, about, and then you fill in the percent of them will result in an interval that captures the actual, could be mean or proportion, weight of the candy. So that's it. We determined a point estimate and margin error, confidence level. That's what we just did in the candy. Interpret a confidence interval in context. We just did that too. The confidence level in context. Describe how the sample size affect. So, how the sample size and confidence level affect the length. If you increase the sample size, you will decrease the standard deviation, sample standard deviation, which will make this smaller width. If you increase the confidence level, you'll increase the critical value, which will make it wider. How practical issues like non-response undercoverage, response bias, can affect this? Well, that's one of those things where if you have something that's biased, it's going to affect and give you bad data. And therefore your interpretation may be bad. But that's it for 8.1. See you next time for Prob Stat 8.2 and 8.3.